Okay, in the last video we saw flowcharts and pseudocode. We just took an example of, we took a very simple example computing salary or pay of employee of a company given hours and rate. And I also described whether the comparison between flowchart and pseudocode, and I said that pseudocode is closer to the code of some programming language, which eventually we need, because eventually we need automation of a solution of a problem, and for that we need a code of the code for the solution, the general solution, in some programming language. So flowchart and pseudocode, and then the code of some programming language like Python. It is somehow and sometimes handy to break the problem or to devise the general solution of any problem in first step in a flowchart, because that is more expressive and more generic, more general, maybe in a graphical way. And then once the proof of concept is clear, once it is clear that this is indeed a general solution, it has no bugs inside, it has no errors, it will work always, then we can take another step to convert that flowchart to pseudocode, and then pseudocode can be converted to the code of the code in some programming language. But writing pseudocode right away, I mean from the very beginning without flowcharts, is also a common practice. Either way, whichever way suits you. In this particular video, I'm going to talk about a problem. The problem is making tea. You might be thinking, what are the different instances of this problem? I mean, making tea is making tea. What kind of different instances are there? Well, one person may be liking tea with, for example, 1.5 units of sugar, whatever the units are. And another person may want a tea with, let's say, 2 units of sugar. One person may be needing a tea with, for example, 0.5 units of milk, and another one may be a different units of milk, and so on. So the procedure of making tea should stay same, and the instances, which means the different people want tea in a different kind of combination, that may vary. So let's see a procedure first in flowchart and then in pseudocode for making a tea. For making tea. So let's start. That might look to you a kind of funny kind of problem, but that's a genuine problem. For example, if you want to make tea, what is algorithm for this? So first we start, and then the first step we do is we put tea bag in a cup. That might be a first step. You can argue, should this be a first step? Should that be the second step, and so on? The sequence of, by the way, solving one problem, you can have multiple algorithms for that. And two different algorithms may just vary because of the sequence of statements, even if you have the same statements. So I'm not talking about that the algorithm or the general solution is unique. You can have multiple different general solutions or procedures. So for example, putting a tea bag in a cup, that might be first step, or the first step might be to boil the water and pour the water in the cup and then put the tea bag. Both are fine, I mean this way or that way. So let's start with putting a tea bag in a cup. So that's an input. We take a tea bag from somewhere, that's our input. Last time I told you that input is taken as parallelograms. Put a tea bag in a cup, and then forget about that cup and boil the water. Somewhere there is a water, I mean take the water from somewhere and boil it. And see if after, let's say, 5 or 6 or 7 time units, whatever the time units are, see if the water is boiled or not. Assume that there is a test that tells you that the water is boiled or not. So there is a test available to you. So you apply that test and check that the water is boiled or not. If it is not boiled, then keep on boiling. So boil it again. And assume there is a procedure of boiling a water. In normal case, boiling water is just happen by, keeping the temperature high or putting the pot of water on fire or something like so. But that itself is a procedure. So boil the water again, and boil the water again. Check if the water is boiled. If no, then boil it again. If boil again, then check. If no, then boil it again. This is called a loop. This is called a loop or repetition. You are doing the same kind of stuff again and again until there is a particular condition that is met. So in this case, the condition is while the water is not boiled, keep on doing the same procedure again and again. This is called repetition or loop. So you boil the water again, check the condition. If the condition is true, for example, the water boiled, yes, then come out. Then you can exit this loop and come out. Then pour the water in the cup. Here we should describe that. Is that the same cup or a different cup? Well, this CUP cup here is acting as a placeholder where this tea bag and the water is going in. So we have a cup, we put tea bag in it, then we put the boiled water in it. But before pouring the boiled water in it, we just boiled the water. Okay, then after we have water in a cup and a tea bag in a cup, what should we do next? We actually we actually first test, want sugar or need more sugar. If yes, then add sugar. So let's apply some arrows. If yes, add sugar, and then again ask, do you need more sugar? Want sugar now? Yes, add sugar. Want sugar? Yes, add sugar. That is again a loop. While you want sugar, I mean, you test that the sugar is okay or not. Here you test that the sugar is okay or not, or whatever sugar you need, is that okay or not. Until that condition is not met, you keep on adding the sugar. Add a teaspoon again, then test, add a teaspoon. That is again a loop or repetition. Once the condition is met, want sugar? No. Then exit this loop and ask, want milk? Because some people just take tea without milk. Maybe somebody wants a milk, maybe somebody don't. So want milk? Yes. So add milk. So that's a mistake. This loop should go there, right there, and this line shouldn't be there. That's wrong. Add milk, and then ask, want milk? Yes. Add milk. That's again a loop. Once you exit the loop, then you ask, need to stir? Yes. Stir. Then ask again. This line again shouldn't be there. So that's another loop. Once you exit this loop, then the tea is ready. You serve that tea, finish, you are done with the procedure. Now let's see the same procedure in pseudocode. Program is a keyword, and that's what program name is. Program make tea. Put is a keyword. Put tea bag in a cup. While water not boiled. While is a keyword. While this condition is not satisfied, keep on doing this. Whatever written in while and end while is the body of this repetition, or called loop. So while water is not boiled, boil water. Then again check, water boiled or not? No, boil again. Keep on boiling. So this is repetition. Once the water is boiled, which means this condition becomes false. Water not boiled becomes false. So water boiled. Then you exit this loop. You pour that water in cup. That's again a keyword. You in a cup, and then you ask, okay, need sugar? Yes, add sugar. Need sugar? Yes, add sugar. So you keep on doing this until you don't need sugar anymore. So that's again a loop. So you might be thinking that why we are writing this add sugar and this boil water to write to this why we are really indenting this. That's a style of pseudocode to just display that this is inside this. This particular statement or set of statements are called the body of the loop. And this end while should be here in this alignment, here in this alignment. So there is a bug in this slide. This should be here. Okay, once this condition is false, sugar needed? No. Then you can exit this loop and you go here. While milk needed? Yes, add milk. Check again. Milk needed? Yes, add milk. Milk needed? Yes, add milk. Once this condition becomes false, milk needed? No. Then you can exit this loop. You can just go to here. While need to steer? Steer T. Need to steer? Yes, steer T. Need to steer? Yes, steer T. Once this condition is false, get out and your T is ready. Do whatever you want to do. This example was so simple, but it expresses a very powerful tool in the pseudocode as well as in flowcharts. And that tool is sometimes called loop, which is there to repeat a particular procedure, whatever procedure you want to repeat again and again until there is a particular condition that is met. That is loop is there. So the purpose of this slide was just to make you convinced and make you comfortable with this pseudocode and flowchart. We will not be talking about flowcharts any further from here on. We will be just talking about pseudocode in just one or two more videos, and then we will be directly going towards we will be comfortable enough with pseudocode for solving certain kind of problems that we will then eventually be moving from pseudocode to actual Python code. And I bet you I'm going to tell you that the pseudocode in the next video I'm going to explain, that will be very, very easily will be converted to the actual exact Python code. So in the next video, we are going to actually solve a problem of finding out minimum value from a list of values, sometimes called the searching problem. We're going to solve it by first using pseudocode, and then in a later video, we will see how to write the actual Python code for that problem. So hope to see you in the next video.